session is conducted, there will be a quiz which will be having 7 problem solving questions which you need to solve out. So keep a check on the description box.
Hi Sukhman.
Hello, sir.
Ji, are we live already?
Yes, sir.
Okay. Okay. So can I start teaching?
Yes, sir.
Okay. Thank you. Hi guys. So this is Sumit Malik from Pep Coding. Um, I will share my screen with you and we'll start doing linked lists. ठीक है, उम्मीद करता हूँ कि आप स्क्रीन देख पा रहे हो. I want the coordinators to confirm कि स्क्रीन विजिबल है या नहीं है. या आप मुझे चैट में ही बता सकते हो. मैं वीडियो खोल लेता हूँ, आप मुझे चैट में बता सकते हो कि आपको स्क्रीन विजिबल है या नहीं है. स्क्रीन नहीं देख पा रहे हो आप. अरे रुको रुको रुको. स्क्रीन इज नॉट विजिबल. मुझे थोड़ा सा टाइम दीजिएगा फिर. थोड़ा इंटरफेस इज न्यू टू मी. Okay, I'm again sharing the screen. और अभी मेरे हिसाब से आपको स्क्रीन दिखनी चाहिए. थोड़ा टाइम दीजिएगा. Yes, it looks a lot better now. ठीक है, ठीक है, ग्रेट. हाँ, ये व्यू सही है ना, यही तो चाहिए था शुरुआत से. बहुत बढ़िया. अरे बहुत सही. ठीक है, ठीक है, मैं भी दिख रहा हूँ आपको और स्क्रीन भी दिख रही है. यही चाहिए था मुझे. ठीक है, आप थोड़ा चैट में बात करते रहिएगा और चैट के अनुसार ही मैं पढ़ा लूँगा आपको. तो साइड में रख दिया मैंने फ़ोन. यार ये वेबसाइट है वेब कोडिंग, मैं तो इसी को यूज़ करके पढ़ाऊँगा. तो हमारे फ्री रिसोर्सेज में ऑलरेडी मैंने बनाकर डाल रखा है. लिंक इसके ऊपर पूरा लेक्चर बनाकर डाल रखा है. सो मतलब वेब कोडिंग में हम ये करते हैं कि हमारा सारा कंटेंट ना फ्री रहता है. ठीक है, तो होम पेज पे ही अच्छे से बता रखा है फ्री रिसोर्सेज. सो यू गो देयर और ये लेवल 1 के अंदर मैं लिंक लिस्ट कराता होता हूँ. ठीक है, तो ये मेरा एक लेक्चर है लिंक लिस्ट. उसमें बहुत सारे क्वेश्चन हैं. तो आई डोंट थिंक कि हम यहाँ पर सारे कर पाएंगे, पर मैं आपको शुरू करवा दूंगा. तो आई थिंक हम इंट्रोडक्शन कर लेंगे और ऐड वैड कर लेंगे. ऐड और डिस्प्ले तक जरूर कर पाएंगे. ठीक है, ठीक है, फिर स्टार्ट करते हैं. बीच में मैं चैट बॉक्स देखता रहूंगा आपका. अगर किसी को कोई क्वेश्चन होगा तो आप चैट में डालिएगा और वहां से आगे बढ़ेंगे. कूल है. ठीक है, सब बढ़िया. इनफैक्ट फोन कहीं यहाँ रख लेता हूँ साइड में, so I can see your chat. ओके, जी करते हैं बात शुरू. क्या होता है लिंक लिस्ट? तो इस लेक्चर के लिए ना मेरा अजम्पशन है, ये अजम्पशन है कि आप लोगों को एरे कम से कम आता है. आप लोगों को पता है एरे क्या होता है. तो जैसे एरे कैसे डिक्लेयर किया जाता है. अगर जावा की बात करूं तो एरे से डिक्लेयर किया जाता है. ARR इक्वल टू न्यू इंट 5. पढ़ना लिंक लिस्ट है, लेकिन हम बात एरे की करेंगे पहले. एक बार एरे की करेंगे, फिर वेक्टर की करेंगे, फिर हम लिंक लिस्ट की बात करेंगे कि क्या समस्या है उनमें, जो समस्या हम यहाँ पर सॉल्व कर रहे हैं. ठीक है, तो हमें कहानी के अंदर एरे की बात करनी होगी, एरे लिस्ट की बात करनी होगी और उसके बाद हम लिंक लिस्ट के बारे में बात कर पाएंगे। अच्छा, मैं सिर्फ एक चीज और जानना चाहता हूँ कि जो ऑडियंस है वो हिंदी जानती है ना? कहीं ऐसा ना हो कि मैं हिंदी बोलता रहूँ और आप लोगों को हिंदी आती ना हो। और क्या मेरी आवाज सही आ रही है आपको? तो मैं पढ़ाने से पहले ये दो चीजें कंफर्म करना चाहता हूँ। मैं ये देख पा रहा हूँ कि स्क्रीन आप तक बिंदास पहुंच रही है। ये मैं कंफर्म करना चाहता हूँ कि क्या तुम मुझे सुन पा रहे हो ठीक ठाक? एम आई ऑडिबल टू यू? चैट में लिख दीजिए अगर आपको आवाज सही आ रही है तो। हम्म। ठीक है, ठीक है। मैं चाहता हूँ आप लाइव चैट में लिख दें अगर आपको आवाज़ सही आ रही है, आवाज़ ठीक नहीं आ रही है, कुछ आवाज़ पढ़ने से पहले हम वो करना चाहते हैं। ओके, आप लोग सुन पा रहे हो, बहुत बढ़िया। ठीक है। नहीं, मैं बेटा सी से नहीं कराऊंगा, मैं जावा से कराऊंगा, लेकिन मैं जो बात करूंगा आप सी में भी इम्प्लीमेंट कर पाओगे, वो कोई दिक्कत नहीं होगी आपको। ठीक है, कूल है। अच्छा जी, तो मैं दोबारा अपनी कहानी पर वापस आता हूँ। मुझे पढ़ाना आपको लिंक लिस्ट है, लेकिन मुझे बात पीछे से स्टार्ट करनी पड़ेगी। मुझे आपको पहले बताना पड़ेगा एरे, और एरे में कमी क्या होती है। जिस कमी को एरे लिस्ट ने सॉल्व किया, फिर भी कमी रह गई, वो क्या कमी है जिसको लिंक लिस्ट ने सॉल्व किया, तो तब हम लिंक लिस्ट के ऊपर पहुंचेंगे। तो सबसे पहले जो एरे डिक्लेयर ऐसे किया जाता है जिससे कि स्टैक के अंदर आपकी कंप्यूटर में रैम होती है। रैम में दो एरिया होते हैं, एक को स्टैक बोलते हैं जो छोटी मेमोरी होती है, और एक बड़ी मेमोरी होती है जिसको हीप बोलते हैं। तो जब ये लाइन एग्जीक्यूट होती है ना, तो होता क्या है, मेमोरी के अंदर स्टैक पर तो एक पॉइंटर बन जाता है। ठीक है, जावा के अंदर ऐसे ही करते हैं तो पॉइंटर बन जाता है, और हीप पर बनता है आपका 5 इंटीजर्स को स्टोर करने लायक एरे बन जाता है। ठीक है, और पहले इंटीजर का जो एड्रेस होगा वो यहां आकर स्टोर हो जाता है 4K। ठीक है, मतलब दोबारा से मैं अपनी बात बोलता हूं, जब आप ऐसे डिक्लेयर करते हैं इंट एरे इक्वल टू न्यू इंट 5, तो हीप के अंदर 5 इंटीजर्स को स्टोर करने लायक मेमोरी को रिजर्व कर लिया जाता है, और सारे वो इंटीजर साथ साथ ही होंगे। ठीक है, और उसके पहले इंटीजर का एड्रेस ARR के अंदर स्टैक में स्टोर हो जाता है। हम्म? तो पहला जो इंटीजर होगा वो 4K पर होगा, तो अगला 4004 पर होगा, क्योंकि हर इंटीजर का साइज 4 बाइट होता है। अगले वाला 4008 पर होगा, उससे अगला 4012 पर होगा, आखिरी वाला 4016 पर होगा। लेकिन आपको ये एड्रेस याद करने की जरूरत नहीं होती। ठीक है, जब तुम बोलोगे एरे ऑफ जीरो, अगर तुम बोलते हो एरे स्क्वायर ब्रैकेट जीरो, तो इसका मतलब ये होता है कि आप पहले वाले एड्रेस पे जाने वाले हो। लेकिन आप अगर आप बोलते हो एरे स्क्वायर ब्रैकेट 1, तो इसका मतलब ऑफसेट रहेगा एक का। अच्छा, अब मैं इंग्लिश तो बहुत अच्छी नहीं बोलता हूँ, पर nevertheless I will talk in English. I'll try to, so that I can express. So when we declare this array, the space is reserved for 5 integers in the heap, and the base address of the first integer is stored in the stack. Hmm. Now, when you want to access the memory for the first integer, you would write array of 0. When you are required to access the memory of second integer, then you would require to say array of 1. So what does it mean when you say array of I? It means I integers away from the base address. So when you say array of 2, so it says 2 integers away from the base address, 2 integers away from 4000. So that means 4008. So when you would say array of 2 equal to 40, so what you are saying is 400. So what you are saying is that you go to the memory which is 2 integers away from the base address of array, that is 4K, and store 400 there. So this would get stored there. All right, so this is about array. This is how arrays work, and it's a very simplistic data structure. That is how arrays work. Now, there are two major problems with it. The first problem that is with arrays is that they are only of a fixed size. Now, initially, let us say initially in the beginning of the program, you were required to store, let us say, 5 integers. Now you declared an array of 5 integers, but later on you are required an array of, let us say, 10 integers. But now array has only a fixed size. It would not grow to 10. So this is the first limitation of an array. This limitation is being removed by array list. So we have just realized the first limitation of the array. an array has a fixed size? Hmm. Okay, Rakshita, I'll try. I'm not very proficient with English, but as and when I'll become more skillful, I'll start posting videos in English. All right. Okay, so the first limitation of an array is it has a fixed size. So if in the beginning of the program you required a space for 5 integers, you declared an array for 5 integers. But now later on you require a space for 10 integers, but you do not have that capability in array. An array cannot grow in size. Now this limitation is removed by array list. Array list or vector. Vector is what is supposedly used in C++. So how are vectors in array list different from arrays? That they can grow in size. That they can grow in size, that you can push more and more data inside it. So that is one thing that array list improves over array. But there is another limitation. There's another limitation, and that limitation is very critical for certain kind of programs, that array is all continuous. Array is all continuous. And you think of memory like a stream. Initially you allocated some memory and this memory is used up. Let us say you took 20 kb and this memory is used up. Then you again allocated something 40 kb and it is used up. And again then you occupied another 60 kb and this memory is also used up. Now in C++ you have that thing available to you which is called free and delete. Now let us say you freed this memory up. This memory is freed. All right. And I think, let us say 20 kb is more remaining here. Now if you are required to create an array of size 20 kb, 20 kb is free here and 20 kb is free here, you can only create an array of 20 kb. Now you cannot create an array of 40 kb, although there is empty space available equal to 40 kb. So I'll explain that part again. This is because of the nature, because arrays only can be in a continuous form. It can only be in a continuous block. They cannot span across empty spaces. So whenever you declare an array, it takes a continuous block of memory. All the memory addresses have to be one after the other. It cannot be like that a few of the memory addresses are in the beginning and the rest three are in the end. So it cannot be done like that in an array. If it is an array, it has to be continuous. So this is the second limitation of an array, that it has to it all its elements will be in a continuous block of memory. But this can be problematic. That same scenario that I was speaking about, let us say you initially reserved the memory for 20 integers, then you reserved the memory for another 40 integers, 40 integers, then reserve the memory for 20 integers. And this memory is still free for approximately 20 integers. And then you went back and deleted this memory. Now this is all occupied, this is all occupied, but you have a memory available for 40 integers free here and memory available for 20 integers free here. All right. So you have memory available for 60 integers, but you cannot declare an array of 60 integers because an array has to be continuous. Although you have memory available for storing 60 integers, but you cannot declare an array of 60 integers now. You can only declare an array of 20 integers, which will have all its elements here, or for 40 integers, which will have all its variables here. Though you have space available to store all the 60 integers, but you cannot store them because an array has to be continuous. So this problem is resolved by a linked list. What a linked list does is it does not store the data continuously. Instead, it stores data in a it uses a node to store a data, and a node has two pieces of information: what is the data and where to find the next data. So I will represent a node like this, so it has data and a pointer which points to where to find the next node. All right. So we had that problem that although we have space available for 60 integers, but an array cannot utilize this old memory because it can only take space in a continuous block of memory. But a linked list is free of it, free from this limitation. So it will declare its first node here. Let us say it has data 10, and then it would have address of the next node here. Let us say that has data 20, and then this would have address of the next next data node here. Let us say it stores data 30, and in the second part of it, it will store information about where the next node is, and that next node can belong to this block of memory 40. Then it will point to the next block of memory 50, and then it can again point back to some space here, 60. So you can utilize the entire empty space. This is how linked lists are better than arrays. They utilize the empty space properly. All right. Now we would see how to declare these nodes. So it is pretty simple. If you are familiar with C++, then you are, I am sure, familiar with concept of classes. In Java, we also have classes. So you can declare this node. In this node, we had two pieces of information. One was the data itself, and second was the pointer to the next node. Hmm. So if you would wanted a node, so it would have two things. First is data, this part. The second is where to find the next node next. So you'll have two informations. One is data, and another is next. This makes the complete node. This is the entire node. It has data, and it also has the information where to find the next node. That is how a link, and linked list is nothing but a series of nodes linked to each other. That is what a linked list is. It has a starting point, and then from that starting point, you move on forward. All right. So I would declare a linked list for you. I'll log in. Hmm. Okay. All right. So this is my class main. If you can see it, I'll maximize the screen, and maybe I should also increase the font. I'll increase the font a little so that you can see it properly. Hmm. And also, I think a lot of you prefer the dark theme. All right. So we have a dark theme. Okay. So I have a simple program here. There's nothing written inside it. There's only a main class, and inside it, there is only one function, main. So main is starting point of everything. Now I want to have a linked list. So what I would do is I would make a class inside it. We need not worry about the word, what does the word private means and the class means. So it is a way of putting data together. So we declare a class called node, and in C we will use struct, because in C there is no class, but in C++ and Java we have classes. So we just need a way to put data together, two things together. One is data itself, and second is where to find the next node. So we'll have these two things. And now we can declare an object from this node head equal to new node. So what this does is, this part, node head new node, what this does is it creates an object for you. This line does, on the stack you will have a variable called head, and when you do new node, a space would be allocated in heap of type node. And because it is of type node, and inside type node we have what, we have two data members. All right. So whenever we would do new node, a space would be allocated to reserve data, to reserve space. We would have memory for both data and next. So it will have two parts to it, data and next. All right. And let's say its address is 4000. So this 4000 would be stored here, but we have not done anything else. So data would be containing 0 and next would be containing null. Now what we can do is we can set this data, head dot data equal to 10. Head dot next, we will not set that now, but we can do this. Head dot next equal to new node. New node. You want even larger text size? Okay, I would have a larger text size. I think you can see it now. So initially we declared this head new node and we set the data to 10. All right. And let me say I declared another node n1. equal to new node, or N2 I would like to call it. And for N2, data is 20. Now I can go back to head and write head dot next equal to N2. So this piece of code, what it would do is, let us analyze what would we get now. This piece of code will have it here instead here. Now we have this piece of information. You can see the node class, and you can also see what we have written in main. Node class is two data members, data and next. Initially we declared a head, then we set the property data to something, then we declared another node and we set its data, and then we pointed heads next to N2. So let us do it step by step. I'll process this information step by step for you. When this information, this line runs, node head equal to new node runs, what happens is a head get declared on the stack and memory is reserved on heap. So node head, it gets declared on the stack. New node, this reserves memory on the heap. But initially both data and next are not set. Data is set to 0 and next is set to null initially. All right. So they do not contain any value in the beginning. So I would write 0 and null initially. Then you said, and let us say it is the address 4K and 4K is stored here. Now this line, when you say head dot data equal to 10, so what actually you are saying is 4K dot data equal to 10. So what we are telling the compiler is go to 4K and set the data property to 10. So this would change from 0 to 10. Now in the next line, node N2 equal to new node. What we are doing is we are creating another node. So another variable would be created on the stack. Another variable would be created on the heap. Let us say it got created at 5K. N2 would contain 5K. Its data would be set to 0 and its next would be set to null. Now in the next line, when we do N2 dot data equal to 20. So what we are saying is go to 5K. Instead of N2 dot data, you should be reading 5K dot data. Go to 5K and the node lying over there, set its data property to 20. So this would get set to 20. And this is now the most critical line. Head dot next equal to N2. Now you have to read it like this. 4K dot next equal to 5K. That go to the node lying at 4K and set its next property equal to N2, which is the next node, 5K. So now you would go here, and instead of null, you would write 5K. And what is the effect of writing 5K? So now this next property points to the next node. All right. Similarly, I could create more nodes and connect them all up. Node N3 equal to new node, and N3 dot data, let us say, is equal to 30. And now I can do N2 dot node points to N3. Now it process this last piece of information. Okay, now when you do node N3 equal to new node, another node gets created here, more space is taken up, and it stores 6K. Then you write N3 dot data equal to 30, so 30 gets stored here. N2 dot node equal to N3. So this is going to change information into N2 node. And what do you want to write in N2 nodes? In fact, I have written N2 dot node is not correct. N2 dot next I should be writing. So when you change N2 dot next equal to N3, you are going to change into N2 node, and its next property is going to be set equal to N3, which is 6K. So you'll have 6K here. Now this would point there. So that is how you create a linked list. Now once the linked list is prepared, you would want to display it. So we can display it pretty easily. We just need to know the head node. What we can do is for node temp equal to head. So initialize your temp to head. And like in array, when you're in an array, you have to move forward, you do I plus plus. But here you would do temp equal to temp dot next. And we would keep on doing until temp is not equal to null. I'll give you a go through in just 1 minute, and inside we can print it. So if you would be on working on C++, you would say C out, but I would say temp dot data. All right. So now let's analyze the last piece of information here, this for loop. All right. It's a pretty simplistic one. So in this for loop, node temp is initialized to head. So a node temp gets declared here. We have not done any new. Temp equal to head means it will also contain the address 4K. And this is now going to run until temp is not equal to null. In fact, I would like to write it not in a for loop, but a while loop, so that you can understand it more properly. Node temp equal to head. I initialize to head while temp is not null. While temp is not looking at something which does not exist. What we would do is we'd go inside the function and write its data value. All right. And then I would say temp equal to temp dot next. Now let's see what we are going to get. Just give me 1 minute. All right. Now you have to process this last piece of information, this information. Okay. So temp is equal to head. So temp contains 4K. While temp is not equal to null. So this is going to run for a long time. While temp is not equal to null. It is not null. So we enter the loop. What we do is we print temp dot data. So 4K dot data is 10. So we print that. We print 10. All right. And then we do temp equal to temp dot next. So temp equal to temp dot next, 4K dot next, which is 5K. So this value gets changed to 5K. Now temp is not looking at 4K anymore. When we did temp equal to temp dot next, so value of temp has to change. And what value has to be put into there, which is written in temp dot next, which is 5K. So we picked that value and we updated this to 5K. Now temp is looking to this information. We come to the top of the loop again. Temp is not equal to null again. So we again enter the loop and we print temp dot data. So 5K dot data is 20. We print 20. And then this line runs again. What happens now? So inside temp, you have to change the information. And where's the information going to come from? It is going to come from temp dot next. So this information is going to get changed because temp is equal to temp dot next. LHS always gets changed. So temp's information is going to get changed and it is going to come from temp dot next, from this information, 5K's next property, which is equal to 6K. So this gets updated to 6K now. The loop moves forward to the top of the loop. We check whether temp is equal to null or not. No, it is not equal to null because it contains 6K. So we again enter the loop and we print temp dot data. But 6K's data is 30. So we print 30 now. And again, this line runs temp equal to temp dot next. Now this is a critical moment. How is that a critical moment? Because now again, this value is going to get changed, but it is going to pick its value from 6K's next property, which is null. So this is going to get set to null. Now again, we move to the top of the loop. We check whether temp is equal to null or not, and it is actually indeed equal to null. So we break out of the loop, we print that full stop, and our linked list is printed. So what we can do is, now we can try to run it once. So what we can try is, I can run it. I will give it a run and let's see. Oh, there's a small problem. Please don't worry about it. I have to write this static and we will not be going into the meaning of static as of now. So this is our final code. We declared the static class node in data node next. Then we declared this head node, which is data to 10. Then these three lines made node n2. These three lines made node n3. And then we displayed it. All right. So I'll be giving you a run. Hmm. So this prints 10, 20, 30. If you can check out the output, it is printing 10, 20, 30. All right. I think I have the text size now set to maximum. Okay, so this is the basics of linked list. That is how you make a linked list. That is how you display a linked list. All right. So we would not be doing the entire lecture now here. What I can advise you to do is you can visit this website, Pep Coding. I would show you where you can. So this is the main website, pepcoding.com, and you can come to the free resources. Our guest has come to meet me. I will not be able to continue further. And you come to the free resources inside level one. I've already created this lecture for you. All right. So you scroll a little down and you will be able to find this link list. So I have created all the questions here. And there's so many questions. You see, there's so many questions on linked list alone. So you can come here and you can solve all those questions. Also, what I want you to know is with every question, there's a solution video along with it. So you can learn all the solutions from here. You will not be stuck. You can practice because you can submit your question and you can also watch the video for any question where you are stuck. And this is not only for linked list. If you would take a look, we have it from the beginning till the end. We have it. We have 5 lectures on recursion, and we have a lot of stuff on DP, on oops, stacks, generic tree, binary tree, binary search tree, all the way to hash map heaps and graphs as well. All right. It was lovely to come over. It was lovely to speak to you guys. Thank you so much. Thank you. Bye bye. Thank you so much. It was lovely to come over. Hi, Sukhman. Can you hear me?
Yes, sir.
Yes, sir. Yeah, beta. So I'm calling it a
Uh,
close. I'm not very proficient with English, so I struggle a little. But there was audience who only wanted to listen in English, so I have to cut it short. Instead, I am giving you that link of my website and this lecture. I've hosted a complete lecture over there of around
okay.
30, 40 questions. So you can give that to people. All right. So I've sent you the link of this website. Thank you so much for
Okay.
hosting me. Yeah.
Thank you so much, sir, for making such a tough topic easier for us to understand from your experience and encouraging us to learn more and more.
Thank you.
Thank you,
Lovely to
sir.
come over. Yes. Bye bye.
Thank you, audience, for being such a patient listener. The quiz code will be shown in the description box soon. The yesterday's winner will be announced. The today's quiz winner will get the t-shirt from the Prep Byte, and the quiz will be conducted on the Prep Byte platform. So please you can check the description box for the code of quiz. The yesterday's winner is Pranedu Bikash Pradhan. So to be the next winner, please come in the description box and get the code and start solving the quiz. Guys, one more thing I want to announce. One of my fellow's mother is currently infected due to the COVID virus and is getting treated in Yashoda Hospital, Hyderabad. She is facing some financial issues, so it would be great if you guys can donate more or less and support us to save her life. The link to donate is given in the live chat as well as in the description box. So you can check.